57% of invoice data out there is still hand-typed from a PDF into a spreadsheet, and 39% of those entries come out wrong. I built a system that reads an invoice and fills in the payee, account number, and IFSC. In my own test runs, a 4 invoice batch finishes in about 14 seconds. I want to show you how it's actually built, not just what it looks like. Most invoice tools either need a template or their OCR bolted onto regex, which breaks the second a vendor changes their layout. And half the invoices people care about aren't even in a spreadsheet. They're buried in Gmail under a subject line that says payment receipt or your subscription renewed, not invoice. So I didn't build one pipeline. I built one extraction engine with 2 doors into it. Browser talks to a Next.js app on Vercel. That's the only thing the user ever sees. It hits 4 N8N webhooks. Extract, extract row, Gmail discover, Gmail extract. Those talk to Google Drive, Gmail, and OpenRouter, running Gemini 2.5 Flash for the actual vision extract. The front end never touches N8N directly. Every one of those calls is proxied through a Next.js ES API. So the N8N URL and the admin token never reach the browser. One decision I made early, N8N never stores a Google credential. Every request forwards the signed-in user's own access token, scoped to drive.read-only and gmail.read-only. Nothing broader. If someone revokes access, that's it. Nothing to clean up on my end. It's more moving parts than a stored service account. But it means I'm not sitting on anyone's Drive or Gmail credential.
Here's one row going through the actual workflow. Upload hits, detect columns. That's a regex pass that matches your header names, so it doesn't care if your column's called drive link or invoice URL. Each row gets tagged with its own index here, because 5 branches downstream run in parallel and scramble the order. There's a dedicated sort rows by index node right before the file gets rebuilt, or you'd get invoice 3's data next to invoice 1's row. If a drive link is broken, that row doesn't kill the batch. The HTTP node continues on error and the row just gets flagged. And this one's subtle. After you download a file, the next code node loses the binary context by default in N8N. You have to explicitly reread it from the previous node or the file just disappears.
Real edge case I hit, Vision Model rejects raw Word documents. And N8N Sandbox won't let you parse a doc-zip structure yourself. So for that one file type, I copy it into Google Docs, export that copy as a PDF, run extraction on the PDF, and delete the temporary copy immediately after. Not elegant, but it's the actual constraint-driven fix. These workflows aren't hand-clicked in the N8N UI. They're defined in TypeScript through the N8N Workflow SDK, validated against the schema, then pushed live through a deploy script. And I keep a Claude.md as a running production checklist. It's caught things like debug logging that shouldn't ship, or an OAuth scope that got accidentally widened before they ever hit production. End-to-end in my own execution logs. A 4 invoice batch, start to finish, in about 14 seconds. Not because I'm claiming some industry average, because that's what my own system logged on that run. And it's not brittle to layout changes, because there's no template to break.
This is the real automation project behind Ledger Lens. 4 separate workflows, all published and live. Together they cover 2 different ways. An invoice can reach the system, sharing one engine underneath that does the actual reading. The first path starts with a spreadsheet of file links. This workflow walks through every row, pulls down the linked file, and works out whether it's a scanned image or a text document, because those need to be read in completely different ways. Both paths run at the same time, side by side, so a slow document doesn't hold up a fast image. Once every row has an answer, they get stitched back together in their original order, and the finished spreadsheet, PIE, account number, IFSC, all filled in, goes straight back to the person who uploaded it. Sometimes only one row needs a redo. A link was temporarily broken, or a field came back wrong. Instead of reprocessing an entire batch just to fix one entry, this workflow reruns the exact same extraction logic, scoped down to a single row. It's the same underlying brain as the full pipeline, just narrower. This is what actually runs behind the retrieve button on the dashboard. The second way in skip spreadsheets entirely. If an invoice showed up as an email attachment instead, this workflow fetches that one file directly from Gmail and runs it through the exact same image or document extraction as the main pipeline. Different doorway, same engine doing the actual work underneath. But you can't extract an invoice, you can't find first. This workflow is the search step that runs before that. It looks across a mailbox for a given date range and keyword, and comes back with the attachments that actually look like invoices, even when the subject line gives you nothing obvious to go on. Four workflows, two entry points, one extraction engine underneath, doing the real work either way. That's the actual architecture running behind Ledger Lens today.
If you want something like this built for your stack, the code's on GitHub, link below.